we are happy to welcome one of our colleagues, Michal Novák, who will inform us about the research of one kind of research on discourse relations. And I should say that next Monday we will be back at discourse. So in a way, this is related to each other. So Michal.
Yeah, thank you. Yeah, sorry. Okay, so thank you for the kind introduction. And yeah, the presentation is mine, but the whole work behind it is not only mine. There's a like bunch of my colleagues that worked on either CorefUD or CRAC Shared Task on multilingual coreference resolution. So you probably know our colleagues from ÚFAL, and these three guys are our colleagues from University of West Bohemia. And there are also some other people who collaborated in some editions or in several editions of the shared task or on the data. So I will be talking about CorefUD, which is the collection of Coreference annotated corpora across multiple languages. And the what I called, or like we shortened it to CRAC Shared Task, but the important thing there is that it's shared task on multilingual coreference resolution. So we have organized this shared task already for four years, and yeah, I want to share with you like some results or like findings from it and what we have learned from it. So first I will like talk or like introduce the whole topic and our motivations for the whole work. Then I will talk about the CorefUD collection, then about the CRAC shared tasks, and then I will shortly talk about LLMs for coreference, especially for coreference resolution, and then I will conclude. So first, coreference, probably I can skip this slide because everybody here knows what is it. So it can be like much complicated or like not so clear as these examples are, but basically it's when two expressions in the text refer to the same discourse entity. So what motivated us for something or preparing something like CorefUD or something like harmonizing the data sets of coreference? So first, like these are the linguistic motivations. We were interested in interplay of coreference and syntax. So you can see it in several phenomena. For instance, the mentions often corresponds to syntactically meaningful units. Some coreference relations are expressed primarily by syntactic means, such as reflexive and relative constructions. And syntax is also useful for identification of zero anaphora or zero expressions. And need to say that we have a long tradition of this joint approach of coreference or joint approach to coreference and dependency syntax in Prague, starting in 1985 by Professor Hajčová, Professor Paneva, and Professor Zgal, and then continued with creating the corpora PDT and PCEDT. Another, this is not that it's still a linguistic approach, but now like kind of applied, like it's a, there was a availability of corpora. So that time when we started in 2020, we saw that there are many corpora annotated with coreference, but they differ a lot. So they differ in the way. Do I have the pointer here? Yeah. In the way how the coreferential mentions are grouped together and how it is annotated in the data. And they also differ in the relation among the mentions. So some corpora annotated singletons. Okay, it's not a relation, it's the characters or the nature of the mention. But some corpora annotated appositions as coreference relations, some annotated predications, and so on. So there's a high diversity in these resources, and from the practical point of view, most of them were in completely different formats, or there were some attempts to create some standard formats, but I don't know, if you take these corpora from CorefUD, from the first version of CorefUD, maybe originally they were annotated in 5, 6, maybe 7, I don't remember, but more than 5 formats. Another motivation, and this was for me more like a computational, as a computational linguist, was that, and is related to the availability of the corpora, is that there have been many approaches to coreference resolution, since, and this table shows only the neural-based systems. So there were also systems before 2017, but when the neural networks started with their hype, and also there was kind of new or reborn interest in coreference resolution. So there are pretty a lot of works on that, but almost all of them were evaluated only on English, and especially on one specific data set, which was English ontanodes. So we wanted to change this, or so we weren't satisfied with that English. Yeah, didn't think that English is the best language to, or if it can be the best language, or yeah, it's not the best language, but still we should evaluate it on many languages because they differ a lot, and they have some phenomena that English doesn't. And another motivation for us was the popularity of Universal Dependencies project. So it's a framework for consistent annotation of morphology and dependency syntax across different languages. And they have been successful in establishing an annotation standard, facilitating NLP research, and serving as a resource for linguistic studies. And we actually had to go in this direction because Dan Zeman, which is one of the main person in UD, was also a member of our team, so there was no other choice. Okay, so these were the motivations for why we decided to create CorefUD in 2020. or 2021. I think we started in 2020. CorefUD, it's a multilingual collection of corpora annotated with Coreference and anaphora. I already said this one, and it's harmonized using the same annotation scheme. Combines annotation of coreference with annotation of morphology and dependency syntax. Coreference is always manual there, while morphology and dependency syntax is manual if it's available or if it's easy to convert to our format. Otherwise, it's automatic. I already told that universal dependencies was a source of inspiration, and at the same time we try to keep the maximum compliance with the standards of UD. And currently in the version 1.3, so we release one version every year. Maybe like at the beginning we released 2 versions in 1 year, but now we try to keep this 1 release per year pace. And so this is the latest release, and containing 28 datasets for 18 languages. So these are the datasets. It's actually split into 2 parts or 2 editions, the public and non-public. Non-public, we do not share it. We do not. We edit only these datasets only for the first version, and we do not or have not extended it like since then. And the reason is that we want to have the data set or the whole collection to be open source or like for free and available. In the latest version, we included these 3, some Korean, Hindi, and spoken French. And here you can see how the size of the corpus or the collection developed over the years or over the versions. So more or less since the beginning it doubled in the number of dataset languages, like sentences and not tokens. We created a new format for harmonize or for annotating the coreference, and like first we started with like in those 0 point something versions. The format was completely different. Then we discussed it with Amir Zeldes and with other people from this Coreference research or field, and we changed the format. And so this format is this CorefUD 1.0 format. And it's fully compliant with ConliU, so that it can be included in UD releases, and the coreference is represented in the MISC column, in the 10th column. So here, I'm not sure if it's clear. It's not very clear. Okay. But so here is this is the annotation of the entity. So here jeho. So it means that the entities, the mention starts here by this opening bracket, parenthesis, and closing parenthesis, that it also ends here. And it belongs to entity number 62601. And this is how we represent the 0 anaphora. So this is a reconstructed subject. So we represent it as a empty node in UD, and actually the annotation of coreference is the same because it's coreferential with this one. If the entity is longer, so it's the case of these, and these are also nested entities. So the entity, the mention, the mention manažér brazilského hráče, I don't know why it's so hard to read, Ricardo Fuca, is starting here and it ends here, and there's also embedded mention brazilského hráče. Yeah. Okay, I don't know why it ends here, but it's probably a mistake. Yeah. Okay, never mind. But it's the format. Yeah, format is clear. Okay, so thanks to Martin Popel, we also provide the API for processing the files, and also like you can also like use it in, or people who are developing coreference resolution tools, they can use this coreference object model in their tools to work with it, or at least to read the files and to easily manipulate the annotation. So it's embedded or like integrated in the UDAPI framework or toolkit for text and UD data manipulation. So you can query, like collect some statistic from it, converse from one format to another, and also visualize. So this is just the example how easy it can be to write the code there. And this is how coreference relations are visualized. So this is some English dataset. So yeah, when you click on one of the mention, it highlights all the mentions belonging to the same clusters, and this is how the mention boundaries are highlighted by those boxes, and I think the dotted mentions are the zeros. No. Yes. No. Singletons. Yes, singletons. Yeah. Zeros are not in English. Sorry. Yeah, but we can see probably zeros here. Yeah, zeros, gray ones. Yeah. Yeah, so this is a Turkish example, some Korean example, and ancient Hebrew. Okay, so we try to add new dataset in each release or each version. But we have some requirements for these datasets. So one of the requirements that I already mentioned is that these datasets need to have free licenses. So that's why we don't share ontonodes in a public version, English ontonodes, and we didn't even included Chinese and Arabic ontonodes in the like non-public version. The other is not a requirement, but our preference now is based on the language, that we want to include more non-European datasets or non-European languages there. That's why last year or this year we added Korean and Hindi. And year before, we added some ancient languages like ancient Greek, ancient Hebrew, Old Church Slavonic. So that's in order to make the whole data set more challenging for the coreference resolution systems. Like in the previous years, we also added some English and French data, which seems to be yeah, they are definitely European and not ancient. But LeadBank is interesting because it's English, but it's fiction or like different domain, and it contains longer longer chains. Even though it is still like criticized that it is still like fragmented, and it can be even like there are like other corpora that contain whole books, and the longers there are even much longer. And Anchor, it contains spoken language, so or speech or transcripts of speech. Yeah. So this is how we select datasets to include, and this is how we actually implement the pipeline. So there are like three approaches that we so far have tried. That either implementing it by our own, by the core team members, which can be like time consuming for us, and another like option was cooperation with of the core team with external volunteers, and also outsourcing with no or weak supervisions. But we had like a mixed experience with this approach, because sometimes they completely forget that there is UDAPI and they don't use it, and then they re-implement things that are already implemented, and so this also, and ideally when the authors of the datasets are interested in like maybe making their projects or their datasets more visible by including it to this collection. Lastly, there's here are some design decisions that we made for creating the collection. So you could see some things from the visualization and also from the format. So we use no mention IDs. So the mention is specified by the full span, so by those parentheses, and the mention may be discontinuous. Then we annotate also the mention head, but we use automatic method for doing this using the dependency tree and like UDAPI, some UDAPI block. And coreference entities or coreference mentions are clustered using co-indexing. So not as you know it from PDT, that in PDT they are connected by links from the anaphor to the antecedent. Here, all the mentions belonging to the same cluster share the same group ID or entity ID. And we allow for singletons. So these are mentions or clusters or entities with only one mention or single mention. Zero mentions, as I said, represented by empty nodes using enhanced UD graphs. And empty nodes may have multiple parents. And at the very beginning, we also included bridging relations, but we do not, like, since the first release, we do not focus on bridging. So we focus more on coreference, and yeah, so this is still thing that can be definitely improved there, and probably there are also some, I don't know, but maybe there are some datasets that we have already included and we did not convert the bridging for them. And I'm not sure, maybe. And morphology and syntax, yeah, UD based, and as I said, Gold, if it's easy to convert, otherwise using UD pipe. So this was about the CorefUD. Okay, perfectly timing. So we had the data set or the collection, and yeah, we want to promote it, and we want it to yeah, there was one of the motivation I've shown on like in the introduction, that the Coreference resolution approaches were tested or evaluated only on English. So we want to create a platform where these approaches can be tested in the multilingual setting using CorefUD data. So we decided to organize a shared task. This is a slide about what shared task is. Probably I don't have to explain what the shared tasks are. So it's a kind of competition, yeah, and providing a common problem, shared data set, and evaluation framework. So we started to organize a CRAC shared task on multilingual coreference resolution, which was collocated with, or is collocated with, the workshop on computational models of reference, anaphora, and coreference. That's why the acronym CRAC. And this year and next year, a CRAC workshop is joined with the CODI workshop, and in the future we're planning, or I think for the not for the 2026, for 2027 we're planning merge the two into like a new workshop under a new name. Yeah, so yeah, and it's based on CorefUD dataset. So the task here is to identify, so in the multilingual setting, to identify mentions in text and predict which mentions belong to the same coreference cluster. Our shared task was definitely not the first one that was organized like for coreference resolution, or especially for multilingual coreference resolution. There, in the beginning of 2010s, there were two shared tasks, SemEval 2010 and CONL 2012. In SemEval 2010, the data included 7 languages. In CONL 2012, it was based on Ontonal's data, so it included those 3 languages: English, Arabic, Chinese. But zeros, or like prodrops or zero anaphora, for SemEval, they don't even state how they deal with, because they definitely have languages or included languages that use prodrops, such as Spanish, Catalan, but they do not state whether they omit them or ignore them, or probably yes, because otherwise they would say something about it in the paper. For the CONL 2012 shared task, they explicitly said that they removed zeros from their data. So this was one of our motivations. So first, we want to include more languages, and we wanted to treat the zeros, yeah, do not ignore them. So in the first years, first 2 years, 2022 and 23, we included zeros, but with the predefined slots. So the teams were given the data where the empty nodes. So if I go back, sorry, to this annotation, so this line was actually given. So the 7.1 was here already, but only this tag wasn't filled, and this was the task for the teams to fill this tag. So they knew where the zeros are. They just have to find their antecedents. Since 2024, we like moved forward and included zeros without the predefined slots. So now the the task is not only identify mentions, but also predict empty nodes. Yeah, and if you compare the number of languages, okay, so we have more languages than. Yeah. So as I said, shared task also provides evaluation framework. So there must be like a very rigid rigid evaluation or specified, clearly specified. So in Coreference resolution, scoring is pretty complex. Like there is no one single Coreference resolution metric, because all of the metrics have some disadvantages, some advantages, and so in the end, what's used is Connell F1 score, which is the average of the MAC, which is a link-based score, B cubed, which is a mention-based scores, and CIF entity, which is an entity-based score. So all these scores are precision recall based, and so you first calculate F1 score for each of these scores, and then you average this F1 score. And in CorefUD evaluation, we then macro average all these F1 scores over all data sets. So it's problem with this Connell F1 score. Yeah, it's established score. The problem with it is that it's not clearly interpretable what it actually means. Yeah, you can say that if the score is higher, then the system is better, but you don't know like what are the weak points of the system, and where it excels. Yeah, you can't say anything from this. Yeah, so these are the scoring metrics, but you have to decide so you have mentions. So mention spans in the gold data, mentions or gold mention spans, then predicted mention spans. So you have to decide when those two mention spans are matched. And there are different strategies to do this. So here's an example. So you have like this mention span. This is a gold mention. This is the mention span, and this is its head. Yeah. And here are different predicted mentions. And traditionally, for English, exact match was used as a strategy for mention matching. So exact match matches the mention only if the whole span is matched. So only in these two first cases, no matter where the head is, these are matched to the gold mention with the exact matching. This is, mentions may be or can be pretty wild when you have like some relative clauses embedded in them, and different appositions, and many things. So this is clearly not the best strategy. So then we rather decided to use the partial match. I'm not gonna explain it, but it uses also the head for matching. But then, since CRAC 2023, we decided to because partial match was like a bit complex, and it had, I don't remember, but it had some disadvantages and it caused some problems. I don't remember now.
People who predicted just had higher partial match score, so they were not motivated to predict.
Yeah. So then we decided to, we decided to use the head match, which compares only the heads, and only in case when you have two mentions, the heads are the same, so then you decide by their span. So spans are used only to disambiguate between two predicted mentions. Since 2024, when we introduced the full support for zero anaphora, we had to introduce also how zeros will be matched, or those empty nodes. So there was no special treatment until CRAC 2024 because they were already in the data. So no mismatch between the tokens or nodes could appear there. But this is no longer guaranteed in the new shared tasks. So and these predicted empty nodes are also not guaranteed to align one-to-one with the gold empty node. So we have to search for the best alignments. So we use the dependency-based matching, and yeah, if I show it, so this is an example. So you have 6 expressed tokens, so they are both expressed in the goal data and in the predicted data, because it's expressed tokens. But in the goal data, you have these 2 extra zeros and this 1 extra zeros, which has actually double dependency. And in the predicted data, the system predicted this 0 and this 0 with these dependencies. And we have to find the best alignment between these zeros, and I don't know why this, it's here, but it's not visible, these circles. But yeah, so between these zeros and these zeros. Yeah, so in this case, it's so we use some priority when the dependency label is the same, these are prioritized, but still if the dependency label is different, it still can be aligned based just on the parents. We also introduce a new score to have a better insight into how the system perform in terms of zero anaphora. So all of these scores actually treat the coreference or look at the coreference or calculate it for the whole clusters, and you can't decompose for every for every anaphor or for every mention, and then just filter out those mentions that you are interested in. So this can't be used for this calculation. So we created a new score. It's okay. It's not a very new, completely new idea. It was inspired by some previous work, but we use this score in our work to calculate the performance on zero anaphora. We also, for our shared task, we also provide the participants with the baseline systems. So the Coreference resolution baseline by the Pilsen guys, by Ondřej Pražák, And this baseline is same each year. This is important. You will see why. And so we do not change it. It's only retrained on new data every year. And empty nodes prediction created by Milan Straka. So yeah, this is a system. Both systems are based on encoder-based models, and yeah, this empty nodes prediction. Yeah, for each word, it selects 2 empty nodes candidates, and by some, and then it has 3 heads to decide on the empty node, whether it's empty node or not, on its word order and dependency relation. Also, we can't use the data as we release it for the CorefUD data as we release it directly for the shared task. So we have to somehow modify it or adjust it for the shared task. Yeah, clearly the non-public data sets are excluded. And so this year, we also made a decision for the first time to exclude one of the already included data set, and it was the Parker-Full, which was the smallest data set, and it has the largest variance across training grounds, so it was kind of unstable, and yeah, we observed it for several years, and this year we decided to exclude it. So non-public are not there. Parker-Fulls are not in the shared task data, and the data also differ in the ways how they are annotated, and we actually release different variants of data, of the same data, for different purposes. So first data type is gold, so we release only train and development data in this data type, and input data where we release only dev and test data with this. So gold it contains gold annotation, so it's almost the same as the original CorefUD release. Input data is it is meant to be the input for the Coreference resolver. So Coreference is deleted, and empty nodes are deleted. But to simplify for the newcomers or people who want just to try and maybe to make the learning curve less steep, we created this starting point, or introduced this starting point. So Coreference and zeros from scratch. In this starting point, the participant have to predict both empty nodes and Coreference, because these are deleted. But if you decide to go from the Coreference from scratch starting point, you already have the empty nodes annotated there by the baseline system. Yeah, that I showed you to the previous slides. But you have to predict Coreference still. And then there's another starting point, which is refine the baseline. So if you just want to do some create a rule-based system that post edits the annotation of the baseline system, so you can start from this starting point where the Coreference annotation by the automatic baseline is also available in the data. Yes. Okay. We tried shared task wouldn't be successful without participants, clearly or apparently. So we need to somehow advertise it. and attract the participants. So yeah, we tried among colleagues, we tried to advertise it through ACL portal, mailing list, or Anya writes the direct emails to authors of Coreference related papers. Yeah, so this is how many participants we had over the years. So not many, yeah, like this is number of participating systems. So like the number of teams is even lower. But yeah, we started with 8 systems. So these are all participants, yeah. And now we have the, like, this year we had the highest 9 systems, yeah. So not too many, but yeah, hopefully it's improving. Yeah, I don't know. And here are the external participants. So those are the participants that are not us, not our students. So they have nothing to do with ÚFAL or University of West Bohemia. So here the number is like, yeah, like this year we had also like we were on par with 2023 with the number of external participants. So yeah, here I'm complaining a bit. So in this point, so it's not easy to attract. So Coreference resolution shifted to the fringes of the NLP research. Maybe that it's only at the workshop, so not many people know about it. But yeah, we try to address them by direct emails. But yes, but we can also probably we also did some organization dissemination mistakes. But yeah, maybe this is we can't expect more from that. I don't know, like, yeah. But still, we are very thankful for the long-term participants, which are obviously 2 of them are organizers, Milan and Ondřej, but also Natalia Skačková from Saarbrücken. Another funny thing, okay, so the winners Conul F1 score, or what about the performance? Yeah, but the winner, yeah, it's every year. It's a core pipe system by Milan Straka. Yeah, I promise that he doesn't. He's not. That we would somehow. He doesn't see the test data. It's just about his skill and that he beats all the competitors every year. So, okay, so this is the chart or the graph of Conul F1 score across the years. So it is around 70 or from 70 to 75, but it's not the best thing to compare it in like only the F1 scores here, because the data and evaluation setup has changed across the years. So they are not directly comparable. That's why the baseline or the baseline is intact for all of the years, or the system is still the same, is important here. So we just retrained this baseline system, and we can see that the task gets more difficult because the baseline gets worse on, like, except for the last year, but I will explain. So if we then just compare these 2 numbers, we can see that each year the improvement of the winner over the baseline was plus 10%. Yeah, except for the last year where the decrease was caused by the removal of parkour full data, where in the previous year like the systems performed exceptionally well on Parkorfu, and it was like a kind of outlier compared to the other systems. Yeah, so you can see that it actually organizing the shared task actually helps in improving the systems for coreference resolution. If we look at the performance on zeros, so this is calculated by that mentioned decomposable score for zeros. Oh, I don't have much time. So you can see the drop in performance after or between 2023 and 2024. So that's because we moved to the more realistic setup. And compared with the baseline, you can see the improvement here as well. Here, this is suspicious that the improvement is so high. I don't know, like there are large drops in baseline performance on check data. I don't know why. I don't know whether we discussed it. Yeah, but we have to look at it. And this is how the traditional system for coreference resolution looks like. So this is Milan's score pipe. And the main point here, which is important for the last part of my presentation, is that it's based on encoder-based model. So with some neural architecture on top, so it labels the text. So last year we were interested in how LLMs can perform in this task. Yeah, so everybody's using LLMs these days, so why not to use it for coreference resolution? But LLMs are different models, so they are decoder-based models, so they are generating text, not the annotation. And there has been previous attempts to these tasks, and they failed to reach state-of-the-art performance, and they were not tested in highly multilingual setups, and of course ignoring zeros. So that's why this year we decided to organize 2 tracks. And actually what I have shown in the previous slide, it was this unconstrained track for traditional approaches, but we introduced a new track, LLM track, that's just to encourage the LLM systems. And we provided the users or the participants with the plain text format with zero support and import-export tools to import the plain text or annotation from plain text to convolu and export it. We also had to reduce the data, so it's not like so computationally expensive. So this year we decided to cap the development and test sets to 25,000 words. And yeah, these were the affected data sets. So this was the final. We kept the data also for the unconstrained track. For both tracks, the participants use the same data, just to be clear here. And as I said, we provided the participants with the plain text format. So yeah, in the plain text there is some mention bracketing, support for zero. So this is these 2 hashes. It's 0, but convolu is still needed for evaluation because, for instance, this 0 only from this plain text we don't know which are its dependency parents. And we don't know where the head is. We only see the spans here, so we still need to use convolu. So that's why we provided also those import and export scripts. You have already seen how many participants we had last year, but if we like split into those tracks, we can see that it's almost half and half in total. But for external participants, yeah, we can say they preferred more LLM track. So maybe like introducing this track was like attracted some of the participants that we wouldn't attract without like advertising it explicitly. So these are the models or the systems that were submitted to the LLM track. And for comparison, this is the winner, CorePipe Ensemble, winner of the unconstrained track and like the total winner. And yeah, so you can see that here in the model column that those approaches were based both on closed source and open source models. The techniques they use, mainly few-shot prompting and QLoRa fine-tuning. And you can see, comparing the context length column, that these LLM-based systems are able to process much longer context at once. But you can also see that the models are bigger. Yeah, this one, CorePipe Ensemble, is like similar in size, but it's because like is the ensemble of the 5 models. So this CorePipe single with comparable performance is much smaller. As for the performance of the models, so within the LLM track, we can see comparable performance across the models, which is better than baseline, but much worse than the best performing traditional system, yeah, by 12 points. But there is still, yeah, it's promising because this is the table of the post-deadline submissions, and we can see that actually the last submission after the deadline by our Pilsen colleagues reaches the 70. It's still not like it's not still doesn't outperform the traditional system, but it's much closer or much more comparable. So hopefully, so this year we called the paper "Can the LLM approaches dethrone the traditional approaches?" or something like this, and hopefully. Yeah, we had to say no this year, but hopefully we will say yes next year. So to conclude, so I presented the CorefUD collection and CRAC Shared Task projects, where we tried to standardize multilingual Coreference data, standardize evaluation framework, and turning attention to some more challenging aspects of Coreference resolution, for instance, zeros. And actually, I forgot to mention there the fourth thing, that it actually helps in improving the Coreference resolution system, as you could see on the graph. Yeah. So. And the last year, we also tried LLMs for Coreference resolution, or encourage experiments and research in this direction. Not successful yet, but we want to like continue in this direction. And for the future work, yeah, we're planning, or already we had to start preparing the new shared task. Now the preparation period has shortened by 4 months, because now usually it was collocated with EMNLP in November. Now it will be collocated with ACL in July, so we have much less time to organize everything and to create or add new data and everything. So yeah, the question, will LLMs dethrone traditional approaches? And yeah, I have not discussed it much with my colleagues, but I would like to focus on the long document coreference resolution, because we could see on the previous slides that LLMs have much larger context than traditional approaches, so they might perform better for these data sets. And yeah, in CorefUD 1.3 we have lead bank, but there are some other datasets that have like longer documents contain longer documents. So we are thinking about including them. Yeah, and there's another future work, and yes, Anya with Katya are like trying to convince me to work on the project about LLM-driven annotation guideline harmonization. So hopefully we will make it happen. So yeah, we will. Okay, so that's us. Thanks to all of my colleagues. Thank you. And that's it. Yeah.
Thank you very much for your talk. And we still have some 20 minutes or so for discussion. So who wants to be the first? Yeah.
I just wanted to ask, there was like a rather long list of different metrics that you can use to measure the agreements. And I basically by chance know just one metrics that's called MASI by Rebecca Passano, and I didn't see it mentioned there. Is it something you couldn't use, or is it like unrelated, or do you know about it at all?
Messi?
MASI.
Oh, maybe it's oh. Okay.
It was used for Coreference, but maybe something different.
There was like alternative names for some of the matrices, but I think only for this Conal F1 score, when it was first introduced by Dennis Baldrige, it was called something like something similar, but probably you are thinking about a different metric. Yeah. Okay. I haven't heard about this one.
We can discuss later.
Yeah,
the details.
Yeah. But yeah, I read a lot of literature about coreference, and mostly these are the most established ones. And like nowadays, everybody measures using Conal F1 score.
Thank you, Michal, for this nice overview. I had no idea what are you doing there, so thanks.
So now you have, yeah?
I have two like curious small questions. First, there was one data set or like two language versions of a data set that you had to put away. I was wondering linguistically what happens there. How is it different from the other ones that you couldn't use it, or what was there? And
you mean the Parkour full data,
yeah? And then second question is, how you collect system description papers for the shared task, or the yes. So maybe I can read it myself, but I'm wondering how actually the few-shot learning for such a thing like a coreference resolution works if you submit an LLM-based system. So
yeah, I don't know actually details of the systems of the participants.
If you have some idea, or maybe if you have spoken to those colleagues who submitted after deadline, how they reached the 17%, that would be interesting to know, right? Even though it was after deadline. So like just
yeah.
If you don't know, you just don't know.
Yeah, I would be just guessing. Like it's definitely some like in context of few-shot learning. I don't know how many how many like examples they provide in the query, but I think like around 5 or 10 examples, but yeah, I'm guessing now, like.
Like, I'm just wondering if this new track brings you more participants, right? Next time.
Yeah. Okay, so, and back to your question about the data. So what happens there? Yeah, like the data is pretty small. It contains, I think, like in the development and test set, it contains of only 2 documents. So it's like pretty unstable, like in the, and since we calculate the macro average S-score, then it affects the whole score, yeah, pretty much, and so like in proportionally to how big it is. But we want to keep this macro average F-score, because if we didn't, then the Czech PDT and I think GAM would be the like largest corpora there, and other corpora with some like interesting languages would be like diminished, or like their influence or effect. So
Okay, thank you.
I will just explain the unstable. It means that the data set is stable. It's not being developed anymore as far as we know. But when you have randomly initialized models, they have always very different score on the test set. That's the instability and why we dropped it.
Yeah, I said it here, or maybe not. So if you train the same systems with the different random initializations, then it gives not completely, but very different results on such a small data set. That's what I mean by unstable.
Because the training data is also small. And then I wanted to explain, I'm also not aware about the details of the winning system, or the one which has 70% after submission, but that's an LLM which is fine-tuned on the correlation which Misha showed there.
Yeah.
And they just fix some technical issues. So it's relatively straightforward. So I think this is an opportunity for anyone working on LLMs. Actually, usually you have problems. Most of the benchmarks are already 99% accuracy. Here you have a benchmark where there is still space for improvement. And we know it's possible because of the traditional core pipe system. So, yes.
Yeah, the interesting thing here was that actually there was not like a big difference between the few shot and fine-tuned models, but this one is definitely fine-tuned. So probably they fixed, as Martin said, some like issues there, and the fine-tuning shows. Sorry? Yeah.
Bohemia, which is the same as the post.
Yeah. This is the same as this one, but this is the new version.
Michal, thank you. I don't want to attack you, but I'm kind of a little bit lost in this direction for the last several years. So we have annotated coreference. Then we have improved our annotations to improve the models. Now the models kind of overrode us, and they give much better results in textual coherence. And we use models to make our coreference resolvers better. So could you? So probably you get the questions like this at large conferences. So what do we make it for?
Yeah, maybe I got lost in the loop, but so yeah, we try to harmonize the data so that you can easily train the multilingual coreference system, and then we can see over the years, and it's not like our job. It's the job of the participants, and especially like Milan, yeah, which is also us, but or who is also like part of our team. But it's Milan systems that can benefit of the data that we are giving to the system in a better way, or it can mimic the annotation in a better way. So the coreference resolution is better. And it doesn't mean, and we do not reflect it in in any way back into the data so far. So so there's no loop, or like if I understand the question correctly, you are talking about some loop, but so far there is actually no loop.
Somehow I think I have lost. Why do we need ideally annotated corporate data sets with coreference? What do we need coreference and annotated data sets for?
Okay, so you are asking like for the why is coreference resolution good for, or what is it good for? Yeah, it's a hard question. Yeah, so difficult to say nowadays because you have LLMs everywhere and you can treat. So in previous years, you could say, and in every motivation, the coreference resolution is good for and can be good for information extraction, text summarization, and blah, blah, blah. These days, you can do it without explicit coreference resolution. But still, it can be interesting. But it's the same with the dependency parsing and part of speech tagging. I would say that this direct motivation for these bigger tasks disappeared. Yeah, so then you have to search for other motivations, like a linguistic research, or also for, I would say that for some, especially, I don't know nowadays, but in few years or several years ago, like companies were more interested in systems that are like better to explain and better to debug, and end-to-end systems are difficult to debug because the bug can appear like in any step. These like multi-step systems are on the one hand worse because the error can propagate, but on the other hand you can see where the error appears, and you can then explain it to your client like easier what happens there. So yeah.
Thank you. I just have maybe an idea what a motivation could be maybe later. Isn't that the case that LLMs are really like energy consuming and that you really need a very good equipment for that? And if you can develop some approach that maybe sometimes later could be implemented in this system, it would work.
Like there's also like a pretty cutting edge research on developing LLMs that can be run on your smartphone, or yeah. So I think still this is yeah. So if you can solve your task, such as summarization, without coreference resolution, that will just introduce some errors that you can explain them, those errors, but you would have like the output would be like probably with more errors than if you didn't use coreference resolver. So why to use it? Yeah, I'd like, yeah, that's also like the thing that I'm still like fighting in my mind with myself, why to continue with this. But yeah, there's still some motivations, or for example the linguistic motivations, and yeah, maybe challenging the LLMs on such a task that is traditional task